So here we are getting some more practice with mixed equations. We just have to figure out what kind of equation do we have, what kind of technique do we have to solve it, and then actually do those things. So in this first example that we're trying to solve, we have x over x minus 1 minus 2 over x equal to 1 over x minus 1. Now I look at this and I think, okay, I've got a lot of variables in the denominator. This is a rational equation. So one of the first things I think about are the domain restrictions, right? Let's see, if regardless of how I go about solving this, if I get x equals 0 as a solution or x equal 1, those cannot be solutions. Those are values that make one or more of the denominators in this equation 0, right? And division by 0 is not allowed. Okay, so if we get either one of those as solutions, we know that they're actually not solutions. So the other thing that we need to be concerned with is what's the LCD, right? Because that's the first thing we've got to do when we're solving a rational equation. We have to multiply both sides by the LCD to clear the fraction. So I see two denominators there, even though we have three, right? In one of the denominators I have x minus 1, and in another one I have x, right? And then in the third one I also have x minus 1. But x minus 1 only appears once in any given denominator, right? So the least common denominator, the LCD, is x times x minus 1, right? So that's what I'm going to multiply both sides of this equation by, x times x minus 1. Here we go, x times x minus 1. Okay, if it's helpful to you to write that on the left-hand side, to distribute that through each numerator and see what cancels, do it. If you can just sort of see what cancels, that's okay too. So if I've got x times x minus 1 times x, that's what I'm going to have in the numerator, right? Over x minus 1. And then here I'm going to have 2x times x minus 1 all over x. And over here on the right, I just have one term, right? So I can cancel out the x minus 1, and I'm going to be left with 1 times x, which is just x. Okay, so I'm going through this step just to show you what you're doing with that distribution on the left-hand side. You're really distributing the LCD through both of those. And then in the first term, x minus 1 goes away, and in the second term, x goes away, and you no longer have a denominator. That's the point of multiplying by the LCD, that you get rid of that. Okay, so over here, I'm going to have x squared times 2 times the quantity x minus 1 equal to x. Okay, so now x squared minus 2x plus 2, I'm just distributing the minus 2 through, equal to x. And what do I need to do with this now? I see the x squared term there, so I know I have a quadratic equation. It's going to have a middle term, so I want to set it equal to 0, right? So right now it's set equal to x, so I need to subtract that x from both sides. So I'm going to have x squared minus 2x minus x plus 2 equal to x minus x, right? And I put that minus x right into the middle since I know I have to combine like terms there. So I'm going to have x squared minus 2x minus x is minus 3x plus 2 equal to 0. Okay, so now I have x squared minus 3x plus 2, okay? This is a trinomial whose leading coefficient is 1, right? So all I have to do is look at that last constant term, c, which is 2, and I have to ask myself, I want factors of 2 that add to negative 3, right? A little treasure map here. Factors of 2 that add to negative 3. So I know that both of the numbers have to be negative, right? So since I add them together, I get a negative number. So negative 2 and negative 1 are the only possibilities, right? And negative 2 minus 1 is negative 3. Okay, so I'm going to have x minus 2 times x minus 1 equal to 0. All right. So, since I have a product now, I know that either x minus 2 equals 0 or x minus 1 equals 0. So I'm going to solve both of these equations. With x minus 2, I have to add 2 to both sides. So I'll have x minus 2 plus 2 equal to 0 plus 2. So x is equal to 2. And over here with x minus 1 equal to 0, I have to add 1 to both sides, right? So I'm going to have plus 1 equal to 0 plus 1. There we go. Okay, so x is equal to 1. All right, so I have these two solutions, x equal 2 and x equal 1. Now, I said right in the beginning, before I even found an LCD, I said if we get x equals 0 or x equal 1 as a solution, it can't be, right? Because if we stick 1 back into the original equation, x minus 1 is in a denominator, right? So if we let x be 1, we're going to get something over 0. That's not allowed. So I'm going to say x can't be 1. I'm not even going to bother checking it. You can check it if you don't notice that, or if you forget to list the domain restrictions. It's good to check them all because it will show itself. When you try to stick 1 back in there, it's not going to work. But let's check 2. Just for good measure, it should work. Okay, so if I stick 2 in here, 2 over 2 minus 1 minus 2 over 2, does that equal 1 over 2 minus 1? Okay, so 2 over 2 minus 1 is just 2, right? 2 minus 1 is 1. So I have 2 minus 1. Does that equal 2 minus 1 in the denominator here is going to give us 1. 1 over 1 is 1. 2 minus 1 is 1. Yes? Yeah. Okay, so that one works out just fine. All right, so the solution set is just 2. We can't use 1 because it disobeys the domain of a term in the original equation. Okay, so this is a good review of how to do this, how to solve a rational equation. Okay, let's move on to this next one. It's 12x squared equal to 13x minus 3. Okay, so again, I see that x squared term in there, and I think, this is a quadratic equation. So the first thing I think to myself is, okay, is there a term with an x in it, like a middle term to our trinomial, or could I take the square root of both sides? I have that x term there, right? And it's not set equal to 0. So when you're factoring, that's the first thing you want to do. To find out if it factors, you got to set it equal to 0. So I'm going to get the 13x minus 3 over to the left-hand side to go along with the 12x squared. So to do this, if this is confusing for you, you can do it one step at a time. But I'm going to subtract 13x, and I'm going to add 3 to both sides. Does that hopefully make sense? So I'm going to show that. I've got 13x minus 13x. Minus 3 plus 3. Okay, so I've got 12x squared minus 13x plus 3 equals 0. All right, so my first question is, I notice that this is a quadratic and it has a leading coefficient that isn't 1. So we might need to use the AC method on this. The next thing I would look for is there a greatest common factor I can pull out? Well, no, because 13 is prime, as is 3, right? 12 isn't, but we're stuck here with looking at this with a leading coefficient that is not 1. So the next thing I would attempt to do is the AC method, right? So I'd multiply 12 and 3 together, and that gives 36, right? So I'd have 36, and I'm looking for factors of 36 that add to negative 13. Okay, so with 36, inside the times table, I automatically think of 6 times 6, but that's 12. I think of 9 times 4. Ooh, 9 times 4, because 9 and 4 would give us 13. And since the 13 is negative and the 36 is positive, then they both need to be negative. So negative 9 and negative 4, if we multiply those, we get positive 36. If we add them, we get negative 13. Okay, so I'm going to use those numbers to rewrite the middle term using the AC method here. So I have 12x squared minus 9x minus 4x, right? Plus 3 equal to 0. All right, now I'm going to do factor by grouping. So I'm going to group the first two terms, and I'm going to group the second two terms. And remember, I always pull the negative out in doing the grouping, right? So if I have a minus 4x there, to keep this the same as it was, I have to have a minus 3 there, right? So if you distribute the negative through, you get minus 4x plus 3. Okay, so now in the first grouping, 12x squared minus 9x, what do 12 and 9 have in common? Well, I can pull a 3 out, right? And then x squared and x, I'm going to pull an x out. So 3x times 4x gives 12x squared, and 3x times negative 3 gives negative 9x, yes? Okay, and then do I have anything to pull out of 4x minus 3? No. So I'm going to have minus 4x minus 3 there all on its lonesome. Okay, so remember this when you're factoring. If you don't have anything to factor out of a grouping, we actually did factor something out already, right? We factored out a -1. So don't forget about that 1 that's sitting there, because really that 4x minus 3, it's a term by itself, right? So we can pull out 4x minus 3 from both of those terms, and we have 4x minus 3 times 3x minus 1 equal to 0. Okay. All right, so now that we have a product, we know that either 4x minus 3 equals 0 or 3x minus 1 equals 0. And to solve them both, in this first equation, I'm going to have 4x minus 3 plus 3, got to add 3 to both sides, equal to 0 plus 3. That will give 4x equal to 3. And I have to divide both sides by 4. So x is equal to 3/4. Now over here with 3x minus 1, I'm going to add 1 to both sides. So 3x minus 1 plus 1 equal to 0 plus 1. So that will leave 3x equal to 1. And I have to divide both sides by 3 to get x by itself. So x will be 1/3. Okay, so I have these two solutions of 3/4 and 1/3. And you look at those and you're like, do I really want to check them? They're fractions. It's good for us. Let's try it. Okay, so stick everything back into the original equation. 12 times 3/4 squared, is that equal to 13 times 3/4 minus 3? So 3/4 squared is 9 over 16. Let's see, 13 times 3, that would be 39, right, over 4, minus 3. And we got to get a common denominator over here. So we've got to multiply top and bottom here by 4 to get a denominator of 4. So 12 over 4 would be equivalent to 3. I could go 12 times 9 and reduce the fraction, but 12 over 16, 4 goes in there 3 times, right, into 12, and 4 times into 16. So 3 times 9 is 27 over 4. Is 39 minus 12 equal to 27? Yes, it is. Cool. Okay, that wasn't so bad. All right, so let's try 1/3. That should work too. So 12 times 1/3 squared equal to 13 times 1/3 minus 3. Okay, so 1/3 squared is 1/9, right? So we would really have 12 over 9 equal to 13 over 3. If we get a common denominator with 3, we have to multiply 3 by 3, so we have 9 over 3, right? Now, over here on the left, 12/9, 3 goes on into both of those, right? It goes into 12 4 times and into 9 3 times. And then over here on the right, 13 minus 9 is 4, right? So I'm going to have 4/3. Is 4/3 equal to 4/3? It sure is. Okay, so the solution set is 1/3 and 3/4. This is a great example because it's a quadratic, it was factorable, but we had to use the AC method, so there was a little bit more involved to it. Okay, great. Let's get some more practice.